Passage 4. Some students conducted experiments using different brands of adhesive tape, one kind each of paper and plastic, a board, and a spring scale. Experiment 1. A student stuck one end of a piece of tape onto the edge of a board that was wrapped in paper. Wrapped board. Tape. The other end of the tape was clamped to a spring scale as shown in figure 1. Okay. While one student held the board, a second student pulled the spring scale until the tape came off the paper wrapping. So in my mind, I'm thinking about what's happening. So one kid's holding this and another kid's pulling here until this comes off. Okay. A third student recorded the force in newtons indicated on the spring scale at the moment the tape came off the paper wrapping. The procedure was repeated for 3 different brands of tape. Each brand of tape, okay, so here's the brands, came in many different widths, of which 2 or 3 were tested. The results are shown in Table 1. Okay, so this was, okay, Experiment 2. The students performed an experiment similar to Experiment 1, except that the paper wrapping was replaced by a plastic wrapping. Okay, so I'm going to, and the results, so I'm going to write paper here and plastic here so I don't forget which table is which. Okay. All right, question number 19. The results of the 2 experiments support the conclusion that for a given brand of tape, as the tape's width increases, the force required to remove the tape from a given wrapping. Okay, so a given wrapping means either one. So, as force, well, we're going to look at what happens as the width increases to the force. So, let's look at this one. As the width increases, we can just look at the average here. As the width increases, the force increases. As the width increases, the force increases. As the width, same thing. How about here? Increasing, increasing, we can't tell on that. So, but everything says as the width increases, the force required increases only. Yes, increases only. Number 20. Number 20. In experiment 2, so here's experiment 2, had brand X tape, here's brand X, in a 4.0 centimeter width, so that would have gone in here. Been tested, the force required to remove the tape from the plastic wrapping would have been closest to, so I'm going to figure it out before I look at my options. So 1, 2, 3, 4, 5, 6, 7, 7-ish. So something close to 7. And look, 5, 7, 9, 11. So G, 7. 7 newtons. Based on the average results of experiments 1 and 2, okay, so we're going to have to look at both of them. Which of the following brands of tape adhered better to the paper than to the plastic? Okay, so we want to know which brand did the paper force, was the paper force greater than the plastic force? Because if it adhered better, it would take more force to pull it off. So, let's see. So this is paper, and this is plastic. Brand X, 1, 2, 3, required more force for the paper than for the plastic. Okay, so brand X for sure. Brand Y was exactly the same. Brand Z, 1.5. We don't have any direct comparison. So and this is reasonably going to be about in here. So they're about the same probably. Let's look at this. Brand X, we know brand Y is incorrect, and so this can't be correct, and this can't be correct. So it has to be A. All right. 22. Which brands of tape was or were used at only 2 different widths in both experiments? Okay. And remember, only is really important. So it can't be more than 2 and it can't be less than 2. It can only be 2. 2 widths in both experiments. X had 3, so it's not that. Y had 2 in both. Z had 2 in one and 1 in one. So the only one that had 2 widths in both experiments was Y. Brand Y only. Here we go. For the students to determine the force required to remove tape from a wrapping, which of the following attractive forces had to exceed the adhesive force between the tape and the wrapping? Okay, so we need to look at our picture of what was going on. We have these forces. And so we have the tape sticking to the paper or the plastic. And then we have this hooked here. So we know that's not going to come loose. What else do we have to make? Here's what we're looking for. This had to hold better than this, because if this came undone, we wouldn't be able to determine what force it took to pull this off. So this has to be stronger than this force. So what did they call that? The force between the clamp and the tape. Boom, that's it. The force between the clamp and the paper, no, there wasn't even a force between them. No, the earth has nothing to do with this. At least not in this part. Okay. 24. The students' instructor gave them a strip of tape that was 2.5 centimeters wide and asked them to identify the brand. Oh, cool, they're working backwards. The students repeated the procedures from experiments 1 and 2 using the tape and obtained an average force of 4.9 newtons for paper and 4.1 newtons for plastic. So we need to find out where would these amounts fit into our charts. Okay, so it was 2.5 centimeters, so we're going to look at paper first. 2.5, could that be 4.9? Yeah, it could. 2.5 is already 5.4. 2.5, could that be 4.9? It could, but it's not very likely because this went up by 2. And this only, well, no, that could have, because that was only half. Okay, so maybe X and maybe Z. So now we've got to change to our plastic number, 4.1. So 2.5, could this be 4.1? Yes, it could. 2.5, no. 1.5 to 2.5, could this be 4.1? Maybe it could be. So I'm really confident of X and I'm maybe a Z. So let's see what we got here. We've got brand X only. That could be. Not Y. Not Y. Not Y. So it has to be only. It has to be brand X only. Okay. Done with passage number 4.